Hi, my name is Diane Sherry-Vastava, and I'm director of the Canadian Institute for Ecology and Evolution. And I'm also lead on the Living Data Project. The Living Data Project is actually run by a large team. We are 19 faculty and postdocs located across Canada. What I'd first like to talk about is what is the Living Data Project? Um, well, it's the solution, we hope, to two problems that we've identified in environmental data science. The first problem is the loss of legacy data sets in ecology, evolution, and the environment. Certainly, there's been a lot of attention paid to contemporary research and the need to make sure that it's open, accessible, and reproducible. But these initiatives are for the present and the future. They really have not thought too much about the past. Yet in ecology and evolution, that is where the really critical data is. That is the data that sets baselines for global change. That's the data that allows us to build population models, look at long-term trajectories in the distribution of species. And it's what we need to build predictions for the future. Yet, ironically, it's the same data that is at a very high risk of loss. So that's one problem. The other problem is, although we have mandated policy-wise the need for open and reproducible research, we really have yet to provide the next generation of scientists with the skills and the tools to do that. So there's lack of formal training at the graduate and postdoctoral level. So the Living Data Project addresses both of these problems simultaneously. And we do that by pairing together the people and the organizations that have the legacy data set at risk of loss with the graduate students that we train in exactly those skills needed to rescue this data. So how does this work? Well, it starts with that team of faculty and postdocs that I described earlier, recruiting researchers or organizations that have the legacy data sets. Often these are researchers who are about to retire and so are at a very good point in their career to want to cement their scientific legacy by archiving their data. But it can also be organizations where they have historical data that really has no data owner to take responsibility for that data. So the first task is to prioritize these data sets in terms of what we want to rescue. And we have a rubric here that thinks about the future potential reuse of the data, so the value of it, as well as the risk of that data being permanently lost. At the same time, we train graduate students across Canada in these 1-month-long courses in data management, in reproducible research, in synthesis statistics, and in collaboration skills. We then run a competition for our trained graduate students to do data rescue internships. These internships are each 6 weeks long. The graduate students are paid $6,500 each, which goes towards their graduate student stipend. And we have established a protocol for environmental data rescue that takes some of the best practices in data management and builds upon these for rescue purposes. So our interns, they compile, they validate, they tidy the data, they code the metadata. They're assisted by undergraduates who we also train. And at the end of this pipeline, the data is posited in open access repositories, so to make sure that they're permanently and openly accessible into the future according to fair best practices. But that's not the end of it, because we also want to breathe new life into this data once we've rescued it. And we do that in a few ways. We create scientific legacy summaries of the senior researcher to acknowledge this contribution. We publish data papers to further publicize the data, and we put together student working groups, again, from our trained cohorts of graduate students where we do synthetic analyses of these data sets. So the program has been in existence now for 3 years. It's funded so far with an NSERC Create grant. In those 3 years, we've had 35 data rescue internships, which engage 25 different government or NGO or academic organizations. We've rescued data from a diversity of systems, from Arctic birds to forest pesticides to watershed manipulations. In terms of the training, we have trained now 193 graduate students in these month-long courses. And in terms of the working groups, these have involved 40 graduate students and 12 established researchers. They've created new analyses of existing data, and they've also created database tutorials for teaching ecology and evolution concepts. So thank you very much.